Namaste and welcome to Apna Gurukul Maths, a little step towards success. We are discussing the chapter Polynomials, class 9th, chapter number 2 NCERT, and we have already discussed about the zeros or the roots of the polynomials. And this chapter, this particular video, is about the remainder theorem, which we are going to study. And this theorem is very, very, very important when it comes to the concept of polynomials altogether. This will be used again and again. Let's begin. To understand, what do we need to understand this remainder theorem? First is division algorithm. I hope you are very much clear with that. That dividend is equals divisor times quotient plus remainder. If you have a little doubt, we will clarify that before we move forward. Then division of algebraic expressions. I hope you are thorough with that. We have different algebraic expression. We try to divide that. This was a concept in class 8. I hope you are clear with that. Now, the third thing, can we get a remainder when we divide algebraic expression with one another? That is the question you need to think while we start this remainder theorem video. Now, you might have been already noticed that it has something to do with the remainder when we are dividing the algebraic expressions. Let's begin. So first of all, quick revision on division algorithm. As I mentioned, it is dividend is equals divisor times quotient plus remainder. Okay, where small d is denoted for divisor, quotient is denoted by q, and r is for remainder. So where q and r are unique and 0 is less than r is less than d. Now, what's the meaning of that? I'll explain it very, very quickly because these are the concepts which you have already studied. So I don't want to spend much time on this. So when I talk about unique, that means suppose you have 12 by 3. So when I write 12 by 3, when you divide, it is written as 12 is equals 3 times 4 plus 0, because the remainder will be 0, and 3 times 4, that becomes 12, right? So is it possible that we get another 4 is the quotient, 0 is the remainder? Now, if this division process continues for 12 by 3, is there any other number which is possible in place of 4 and 0? Let's take another example. 15 by 2. If you divide 2 and 15, you get a divisor as 7, 14, and then 1 as the remainder. Is there any other possibility that instead of 7 as quotient, you get another number 5, 10? No, right? That's not possible at all. So that's 7, and obviously the remainder will be 1 in this particular case of division. So how can we write in terms of division algorithm? 15 is equals 2 is the divisor times 7 is the quotient plus remainder is 1, right? So in this case, the the quotient and the remainder is unique, and as well as what is the possibility of remainder? A remainder is either 0, as we have already seen. So 0 is less than or equal to remainder. That means the numbers which are less than or equal to 0 means remainder is greater than or equal to 0. 0, obviously here we got here 1, which is obviously greater than 0. Now, what does this mean? It should be less than the divisor. Now, this type of statement is called as inequality, which will be used again and again in our discussions or as we go to higher and higher classes. So we must be a little bit better with that. So that's why I'm taking a little more time. So what is the meaning of that? R is less than the divisor. Whatever divisor over here, the divisor is 2. So there is no possibility that the remainder can even be 2, because there is no equal to here. It says it is less than always, and that is possible in any kind of division. That is what division algorithm is. The remainder is between 0 and the divisor. It can be 0 but not equal to or more than the divisor. Over here also you can see divisor is 3. So the remainder could possibly be 0, 1 and 2. If the divisor is 5, what are the remainders possible? 0, 1, 2, 3, 4. Yes, I hope that is clear by now. Let's get going to the next thing. Now, once we write like this and the remainder is 0, so I'll write it little neatly. 12 is equals 3 times 4. Can I write it like that? So what is the meaning of that? According to factors and multiples, that 12 is a multiple of 3 and 4. Yes or no? And 3 and 4 is a factor of 12. What is the meaning of factor? a bigger number, whatever smaller numbers can divide that bigger number properly with the remainder 0, they become the factors. So over here 3 and 4 are the factors, and 12 is a multiple of 3 and 4 both. So this observation and the division algorithm are the basis for what we are going to study in detail about remainder theorem. So same thing, same division algorithm is followed for division of polynomials as well. Now we started with division of algebraic expressions. Obviously polynomials are also a type of algebraic expressions, right? So the same criteria is followed. We will start with a few example of division. Now, so far in class 8, whatever division you would have done with algebraic expression, you will never get a 0. You might not have ever got a 0 as a remainder. But let's try to do some division here. Are we getting a 0 in, are we getting a remainder except 0? Let's try to understand. So over here we have a division 3. We have 3y square plus y plus 1 is the dividend, and the divisor is y. So y, we start the division process. 3y square plus y plus 1. Yes. So now when we start the division, obviously there is only one term in the divisor. So at one time we will consider one term of the dividend. That's the first thing we observe. So y and 3y square. So what should you multiply to y to get 3y squared? It's 3y, right? 3y multiplied by y will give you 3y square. Now once we are, obviously while we follow the division we subtract, right? So this plus sign changes to minus every time the sign changes when you are subtracting. For that you can think of, over here we are subtracting two algebraic expressions. So when we are subtracting, the sign changes for the other equation. If you want to if you have a little bit doubt why do we change that sign, you can comment down. I'll make a separate video altogether to explain that. I hope that makes sense. Let's move, let's get going. This is 0, so now we cannot further, so we will bring this y down, and then we multiply it by plus 1. So plus 1 times y, again I get a y, and then when I subtract, I get a 0, and this plus 1 comes down. Now this plus 1, can we further divide? Can I multiply something to y to get a plus 1? Obviously not, right? So this plus 1 becomes the remainder. Now this observation, this particular observation will give us the division algorithm, especially for polynomials or algebraic expression. I will explain that in a little while, but before that let's focus here. We got a remainder 1 over here. Yes, so in this particular we got the remainder as 1. Can we say that y is a factor of 3y square plus y plus 1? Absolutely not. Because to say that y is a factor, remainder must have been 0, as we saw in this case, right? Over here in the other case, which I took, 15 equals 2 times 7 plus 1, we never say that 2 is a factor of 15, because the remainder is 1 over here. Similarly, since we have a remainder which is non-zero, y is not a factor of 3y square plus y plus 1. This is a second observation. Keep it in mind. We are collecting everything to bring out the theorem which we have. Let's take one more example very quickly. Okay, so here we have the divisor as 1 plus x, and the divisor is 1 plus x, and the dividend is x plus 3x square. So we will arrange it in standard form, 3x square plus x minus 1. Yes. Now when you are arranging in divisor standard form, make sure you do not mess up with the sign. 3y square has a positive sign, so I took the positive sign. If it was negative, I would have taken the negative sign altogether. I hope that makes sense. Let's get going. So I'll make this x plus 1 also in standard form. Let's work in standard form. So 1 plus x is nothing but x plus 1. Now once again, how many terms in the divisor? 2 terms. So we will consider 2 terms at one time from the dividend. Let's get going. So what should you multiply to x to get a 3x square? So we must multiply 3x. So 3x multiplied by x, you get 3x square. And then 3x multiplied by plus 1, you get plus 3x. Yes? So now the sign changes, minus, and this becomes minus 3x minus 3x square, this get cancelled out, we get 0. So x minus 3x, we get minus 2x, and this minus 1 comes down. Now again we have two terms and two terms in the divisor, so we can proceed forward. So x plus 1, what should you multiply to x to get minus 2x? Obviously minus 2 I should multiply. So minus 2 times x, we get minus 2x, and minus 2 times plus 1, we get it as minus 2. So we get a positive value over here because the sign changes. Over here we get once again a positive. So they become 0 because minus 2x plus 2x is 0. So minus 1 plus 2, we again get the remainder as 1. Now we are again and again getting the remainder 1. So don't think every time we'll get the remainder 1. We'll get all types of remainder. Now, can we proceed further? Obviously not. We cannot multiply anything to x plus 1 to get a 1, right? So 1 is the remainder here as well. So the remainder is again 1. Yes. Can we say that 1 plus x is a factor of x plus 3x square minus 1? Absolutely not. Yes. Let's go through one more multiplication and then try to find out if we can say it as a factor. Oh, I'm sorry. Yeah. Can we say, let's try to understand, can we say that if it's a factor or not? Let's get going. So now we have a little bigger division. So please be a little bit patient while doing it. If you are very much confident about the division, you can quickly skip this part and directly go where we write the quotient and remainder, and discussion continues. Okay, x to the power 5 plus x to the power 4 minus 2x to the 3 minus 2x square plus x minus 1. Yes. Now x plus 1 plus x, I will write it in standard form to make the consistency. So this becomes x plus 1. Now two terms, so we need to consider two terms at a time. So let's begin the division of this particular algebraic expression. So x plus 1, we need to multiply to x to the power 4 to get this x to the power 5. So x to the power 4 multiplied by x, we get x to the power 5, x to the power 4 multiplied by plus 1, we get x to the power 4. Yes. Now when we subtract, the sign changes, and x to the power 5 minus x to the power 5, this also get cancelled, this also get cancelled. So we will bring the other two terms down because we need two terms to operate at the same time. Then we get minus 2x square. Now what should you multiply to minus 2x cube? To x to get minus 2x cube. So we must multiply minus 2x square. Now if you have a little bit doubt on how are we operating in this division process, you can again comment down. I'm very ready to explain this, but since this is not the main topic, I'm going a little bit faster. Okay, so minus 2x square times x will give you minus 2x cubed. Minus 2x square plus 1 will give us minus 2x squared. Yes, so this becomes a plus, and then again this becomes a plus. Yeah, so then when we subtract, again it is cancelling out very easily. Yes, it is going to cancel out because minus and plus, so they get cancelled out, minus and plus, so they get cancelled out. I am remaining with x minus 1 over here. Now x minus 1, so what should you multiply to x to get a x? Plus 1, obviously. Okay, I will make a little bit change over here. Okay, so instead of minus 1 here, let's make it plus 1. Okay, I'm doing this with a purpose. Instead of minus 1, I'll make a plus 1 over here. So x plus 1 multiplied by plus 1, you get plus 1, and then you get a 0. The remainder came out to be 0 over here. What is the meaning? That 1 plus x is a factor of x to the power 5, means what? This complete polynomial. But we could not have said this if instead of x plus 1 we would have x minus 1. Yes, so that is one thing we must be very much careful about. So over here we saw one example where we got the factor. The only condition is remainder should be 0. So now let's observe whatever we have done so far. Okay, let's observe a few things according to what we have done so far. So let's find the roots of the divisor of the polynomials in the example. Okay, divisor in the polynomials, whatever we took over here, y is the divisor. In the second one, x plus 1 is the divider. Over here, x plus 1 is the divisor. What are their roots? For y, it's 0. For over here, the root for 1 plus x is minus 1, and 1 plus x is again, the root is minus 1. I hope you are clear with the roots. I mean the zeros of the polynomial. You just equate x plus 1 equals to 0. So x equals plus 1 goes to the other side. We get minus 1. Now, once we equate y to the 0 over here, the divisor is y, right? So once we equate y is equal to 0, so obviously the 0 of this divisor, that is y, is 0, right? Over here, it's minus 1. Let's understand what. Find p of root of the divisor. What is the meaning of that? Here we have this polynomial, the dividend, right? So dividend, we generally represent it by p of x or q of x. So we are, what is being asked? We have to find the value of the polynomial at x is equals minus 1, because minus 1 is the root of the divisor. Let's try to understand that. Okay, now do not get confused. This is a little new things for you, so please pay attention. You will understand it really nicely. Okay, so we have to find p of root of the divisor. Yes, root of divisor. Now what is the number for the root of divisor? 1 plus x, so it will be minus 1. So we have to find the value of p of minus 1. So p of minus 1, when we try to find, instead of x we put minus 1 plus 3 times minus 1 the whole squared minus 1. So we get minus 1, 3 times plus 3 times minus 1 square is 3 minus 1. So what do we get? Minus 1 is minus 2. So 3 minus 2, we get it as plus 1. Now please be careful. We got the value of p of minus 1, where minus 1 is the root of the divisor as 1. And what is the remainder we got? Remainder, we got it as 1. Yes or no? So the remainder over here, can I say that p of root of divisor is the remainder? Let's try to verify with a few more examples. Over here, in this case, I'll name this polynomial as p of y. Okay. So for this particular case, we will try to calculate the value of p of y. Let's try to change the ink and then continue. So p of y, we have the polynomial, and the 0 of the polynomial is means 0 over here. The root of the divisor, I'm sorry, root of the divisor is 0. So p of 0, 3 times 0 square plus 0 plus 1. So 3 times 0 is 0, 0 plus 0 plus 1, we get it as plus 1. Again, the remainder was plus 1, and p of 0 is also plus 1. Yes or no? So what do we observe once again? That p of root of the divisor is equals to the remainder. Let's try to observe for the third one as well. This is becoming a little bit interesting. Now, what do we need to find? What is the root of 1 plus x? It is minus 1, right? So q of minus 1 equals x to the power 5 we have. So minus 1 to the power 5 plus minus 1 to the power 4 minus 2 times minus 1 to the power 3 minus 2 times minus 1 whole square plus of minus 1, because x, and then plus 1. Quickly go through this. Minus 1 to the power 5 is minus 1. Minus 1 to the power 4 is plus 1. Minus 2, here we have minus 2, and minus 1 cube is minus 1. So minus 2 times minus 1 is plus 2. If you got confused, go back and listen to me once again, you will understand it. Then once again, minus 2 times minus 1 square is 1. So minus 2 times 1 is minus 2. Now in this case, we were doing minus 2 times minus 1. That's why I wrote plus 2. Over here, I'm doing minus 2 times plus 1. That's why I wrote minus 2. Then plus minus is minus 1 plus 1. So minus 1 plus 1 is 0, plus 2 and minus 2 is 0, minus 1 and plus 1 is 0. So what do we observe? That q of minus 1 equal to 0. Isn't it a very interesting thing? Instead of going for so long division method to find the remainder of a particular polynomial divided by polynomial, why not find the root of the divisor? Now, my dear friends, observe here. This particular observation is only when we have the divisors, all of the divisors are linear polynomials. Do we observe that? Yes or no? So, this is possible only when our divisors are linear polynomial. I hope that was a very good observation for you to make. Yes. So over here we have already done this particular thing. So let's get going. What was the observation? That P of root of the linear divisor is equals to remainder of P of x by G of x. Yes or no? Where G of x is the divisor, obviously. Let's try to understand the division algorithm for polynomials, and then we will get on to the remainder theorem of remainder theorem, obviously. So division algorithm for polynomials. When I was dividing, I asked you to please pay a little attention on that. Yes. So division algorithm for polynomials, P of x equals G of x. G of x is the divisor times Q of x. Q of x is the quotient. R of x is the remainder. Now, obviously, they are all written in terms of x because all of them are polynomials. Now, what is the observation here? Where degree of P of x is the dividend, is greater than G of x. That means degree of dividend is always greater than the degree of divisor. That's the first thing. And G of x is obviously not equal to 0. Never, we can never have the divisor as 0. I've already discussed this in the number system chapter. You can go to number system. It might be in the description, and in the playlist also you can go through the number system. You'll get to know about that. Why can divisor be never equal to 0? Then we have the third condition over here, degree of G of x. That is, G of x is the divisor. So degree of divisor is greater than the degree of the remainder. Over there, when we had numbers, we said that the remainder is always less than the divisor. Here, what do we have? The degree of the remainder is less than the degree of the divisor. I hope that makes a lot of sense. So let's get on to the definition of remainder theorem. The definition says, let P of x be a polynomial. Okay, of degree greater than or equal to 1. Yes, it can be a linear polynomial as well. Why? Because we have the divisor with a degree 1. That is why it is saying the dividend P of x is the dividend. So dividend has a degree of greater than or equal to 1, because remainder theorem, what did we study? That the degree of P of x is always greater than or equal to G of x. So obviously the dividend can be a linear polynomial or greater polynomial than that. And let A be a real number. Now, why are we assuming that? I'll tell you. Now, if P of x is divided by a linear polynomial x minus A, right? A is a real number. So x minus a is a linear divisor. Yes. So if P of x, the polynomial, is divided by a linear polynomial, then the remainder is P of a. Why P of a? Because if x minus a is the divisor, what is the 0 of x minus a? Equated to 0. X equals a. That is why, what do we observe? The remainder is P of a. Or we can also say that P of the root of divisor. Yes, whatever we observed, that became our theorem. I hope that makes a lot of sense. Let's try to do a few problems. Before that, let's try to prove the remainder theorem. Now, proof is generally not asked in examination, but to understand the theorem nicely, we must understand the proof, and the proof is very easier. So we will be able to do it a little faster and a little fun way. So again, we will assume what is assumed in the theorem. Let P of x be a polynomial of degree greater than or equal to 1. Suppose that when P of x is divided by x minus a, the quotient is qx and the remainder is r of x. Yes, why? To apply the division algorithm. So quotient and remainder we have. So according to division algorithm, P of x equals x minus a times q of x plus r of x. Yes or no? Now, according to division algorithm, what did we say? The degree of the remainder is less than the degree of divisor. So the degree of divisor x minus a over here is 1. Now what is less than 1? It's 0, right? So the degree of remainder should be 0. Yes, remainder's degree is 0. That means when do we have the degree 0? When we have constant polynomial. That means over here, r of x is less than the degree of divisor. So the degree of r of x is 0. This means r of x is a constant polynomial. So since it's a constant polynomial, it does not depend on the value of x. We will represent it by r. Say that the degree of, say the remainder r of x is nothing but r. So for every value of x, r of x equals r, because whatever value of x may be, r is never going to change because r is constant polynomial, and constant polynomial does not depend on the value of x, right, on the variable. So therefore, what do we have? P of x equals x minus a times q of x plus r. Is that clear? Now, in particular, if I take the value of x as a, why am I taking the value of x as a? Because what was the theorem? That we have to find the value of p of a. That is why I took the value of x over here, p of x, right? So I took the value of x as a. So x, if I take the value of x as a, so we get p of a equals, instead of x over here, we substitute a. So a minus a times q of a plus r. That is that implies p of a equals a minus a is 0 multiplied by q of a. We are not bothered about what is the value of q of a, because 0 multiplied by anything is going to be 0. 0 plus r, that is equals to 0. Sorry, I'm sorry, that is equals to 0 plus r is r. So that means p of a is coming out to be the remainder of the division of p of x divided by x minus a. I hope that makes the remainder theorem very, very much clear for all of you, and the proof as well. Now, proof is generally not asked in exam, but to understand how to apply that, proof is always important. So I have already told in my introduction video, we are not at all worried about exam. We are focused on learning maths to develop ourselves. Okay, let's go get on to few questions. So suppose the value of, we have a polynomial p of x equals x to the power 4 plus x cube minus 2x squared plus x plus 1. We have to divide it by x minus 1. So again, what do we have to do? We have to check the remainder of this. So x minus 1 is the divisor. What is the 0 of this divisor? Equate is to 0. That means x equals 1. So we have to find the value of p of 1, and we have found the remainder. Yes, that's what the remainder theorem says, right? How easy process it is. So p of 1, so instead of x, we are substituting 1 to the power 4 plus 1 to the power 3 minus 2 times 1 square plus 1 plus 1, because x is substituted with 1. Yes, I hope that's clear. And then 1 to the power 4 is 1 plus 1 minus 2 plus 1 plus 1. So 1 plus 1 is 2, 2 minus 2 is 0, plus 1 is 1, and then 2. So what is the remainder in this particular division is? That implies remainder is equals to, why? Because p of 1 equals 2. And why only 1? Because 1 is the root of the divisor. Now, the other aspect of this remainder theorem, we are being asked, check whether the polynomial q of t, 4t cube plus 4t square minus t minus 1 is a multiple of 2t minus 1. When can we discuss about multiples and factors? When we have the remainder as 0. Yes, let's try to understand that. But before that, let me write this particular division in the form of division algorithm. So how will that be written? Dividend, that is equals x to the power 4 plus x cube minus 2x square plus x plus 1. Oh my goodness, that's so big. X plus 1. This is the dividend. This must be equal to g of x. What is g of x? X minus 1. That is the divisor. What is the quotient? We don't know, and we are not worried about the quotient right now. So we will write it as q of x plus what is the remainder? Remainder will be 2 over here. We are very, very much confirm about that. So q of x plus 2, and that's all it is. Yes, that's how we will write. Now, if this remainder would have been 0, we can say that this divisor is x minus 1 is a factor of this particular polynomial, or this polynomial is a multiple of x minus 1. I hope that makes sense. Yes. Let's try to do the second question. The second question says we have to check whether the polynomial for q of t equals 4t cube plus 4t square minus t minus 1 is a multiple of 2t minus 1. We can only say that when the remainder is 0. So let's try to first find what is the 0 of the divisor. 2t minus 1, what is the 0? Let's equate it to 0. So 2t equals, this minus 1 goes to the other side, it becomes plus 1. That means t equals 1 by 2. So what do we have to find? We have to find the value of q of 1 by 2. Let's quickly do it. So that is equals 4 times 1 by 2 cube is 1 by 8 plus 4 times 1 by 2 square is 1 by 4 minus 1 by 2 minus 1. So 4 ones are 4, 4 twos are 8, 4 and 4 gets cancelled out. So what do we get? So this becomes 1 by 2 plus 1 minus 1 by 2 minus 1. So 1 by 2 plus minus 1 by 2 plus 1 minus 1 gets cancelled out, and we get the remainder as 0. That means q of t, this polynomial, is a multiple of divisor 2t minus 1. I hope that makes sense. Or we can also say that 2t minus 1 is a factor of 4t cubed plus 4t square minus t minus 1. And that is the, I would say, a hint for the factor theorem. We will discuss it in the next video. Thank you so much for patiently being with Apna Gurukul Maths. And I hope you understood this remainder theorem very nicely. We will understand the applications in the coming videos, probably after a week or so. And if you like this video, please do like and subscribe. Thank you so much for being with us. See you in the next video. Until then, keep smiling. Jai Hind. Apna Gurukul Maths. One little step towards success.